Hey, everybody. This is the first session of fall offering of CSCE 181 Introduction to Computing course. My name is Akash Tyagi, and I'm your instructor. Due to extenuating circumstances, I'm not able to be with you in the first week of this class, but we will see each other in the second week of this semester. Okay, so we'll talk a little bit about our class and the grading policies, and then we'll move on to talk a little bit about the field of computing. So what will we learn in this class? Well, it's an introductory exposure to the field of computing and computer science. A very traditional thinking of computer science equates it with programming, but it's way more than that. So what we are planning to do in this class is to invite presentations to take a look at some diverse fields in computing and computer science. After all, my interest is to motivate you in different fields of computing and computer science. And this is a perfect place for us to come together uh, to hear from experts in some cases about the possibilities. At times, we'll also have testimonials from industry practitioners about the applications of the field. We'll have a conversation on explaining the major, computer science, computing, computer engineering. We'll talk about some practical issues faced by software developers. And then in the early part of the semester, we'll spend some time talking about internships, career, research, and grad school. So a whole lot of stuff here in coverage. So for this course, it's the teaching staff is myself, and you can always drop me an email or send me a message in inbox on Canvas for appointment over Zoom. And our senior grader assigned to this course is Harsh Surolia, and you can certainly contact him for any questions about your course grade. The logistics are we'll meet every Tuesday, 12:45 to 2. So just to give you a little historical context, I mean, this is a 1 hour class, 1 credit hour class. In the past, it has run twice a week for half of the semester, roughly half of the semester. But I found that it tends to overload things a bit, and you don't really get to enjoy a topic and the course as much. So what we're planning to do is just meet once a week, Tuesdays, and we'll meet throughout the semester. So every week we look forward to coming together to tackle a new topic. Now, on exception basis, sometimes I might schedule a class on Thursday in its specified time. But if I do so, I will give you a week plus notice through Canvas announcement. So we're going to meet online over Zoom, and on our Canvas page right here, you can see in modules we have the student resources module, and then if you click on Zoom logistics, you're going to be presented with a link to how to attend this class. I have license to host up to 500, so I don't think we should be bothered with any concerns for capacity, but we'll see how it goes. Okay, there's two important things I need to point out to you for logistics, and these are in your best interest. So first of all, to attend this class, you have to sign on to tamu.zoom.us with your Tamu Net ID. And this is the only way we can record your attendance. Uh, of course, Zoom is a platform available to non-Tamu addresses as well, but for us in this course, you have to attend through your Net ID on tamu.zoom.us. So before coming to class, I suggest that you log in to this website to get any kinks out of the way, because in the past, I've noticed that some students were surprised, and at the very end, they were not able to attend the first class because for some reason, they were not able to authenticate in time to the TAMU site for Zoom. So that's the first step. Please take care of it even before you come to class on the second week. The second one is to make sure that your full name is registered with TAMU, and that shows up in Zoom. So the way to do it is you again go to tamu.zoom.us and /profile. And when you go to profile, this is an example for myself, so it'll pop up here. And in edit, you click on this edit, and then you can actually put your name. So just in case in the past you have changed the way you appear to Zoom, please go back and make sure that your first and last name are clearly shown in Zoom. Because these are the only ways in which we can register your attendance. And as you'll see, a big part of the course policy is tracking through attendance, and we can do that only if you follow these two steps. So we host this course on Canvas. We just looked at it. We'll use it for announcements. Our syllabus is posted as well. And so again, take a look here, go to modules. It's also available through the homepage, but here we have the syllabus posted on Canvas. Same copy is posted on Howdy as well. Okay. All right. The other thing we use this Canvas for is content. So we will put presentations like I've done here. So again, go to module, and below the student resources, you'll see all these weeks pop up. So in week 1, we have the presentation, and this will include both the presentation slides as well as the video recording of the sessions. The video recordings will be posted after the session is over. So it typically takes about half hour for the recording to complete processing. And then after that, I post the Zoom link for video recording. The other thing is that we'll also be posting an associated quiz to every presentation. And I'll talk a little bit about that in a moment. So that's what you'll see Canvas. Okay, this one is a busy slide, but I'll go through it carefully because it deals with your grade. So the grading there's a big component is attendance. And again, we talked about the 2 rules. One is you have to authenticate through your net ID on tamu.zoom.us. And the second is that your first and last name should show up as your profile in Zoom. So those are 2 rules. Please take care of those. Now let's talk about the course grade. So I expect total 14 session. If there's more than 14, you are still held to the criteria for 14. So in other words, if we end up having 15 sessions, you just get 1 bonus credit for that. Okay. For each session, we log the seminar attendance on Zoom, and then we have a follow-on quiz on Canvas. Okay. The quiz is based on the session content, and it's going to be released online on Canvas every Wednesday morning. So we meet on Tuesdays, and then by Wednesday morning, I will post the quiz online. And it's likely going to be true, false, multiple choice, stuff like that. I don't expect to be asking you to write essays at all. Now, we're going to post this quiz on a weekly basis pertaining to the session content every Wednesday morning, and you will have until 11:59 p.m. on Friday to finish. So Wednesday, Thursday, Friday. I mean, 3 days. No exceptions made for any delays. These 3 days account for all sorts of contingencies. The quizzes are going to be easy. If you attended the class, and then obviously we invite you to take the quiz. If you did not attend the class, it's okay for you to take the quiz, but you will not get credit for that session because part of the credit is coming from attendance, right? So it's completely up to you. If you attended the session, though, you have to take the quiz in order to get full credit for that session. For the quiz, we'll give 2 attempts, and the highest score will be taken. Okay, a score of 70% or higher is considered passing, so it's just pass and fail. So for each session J, a pass is recorded if attendance J is true and quiz J grade is pass. Okay, it's pretty simple. Okay, and the course grading scale is A is greater than or equal to 85%, and then of course B over between 75% and 84.999%, and C is more than 65, and so on. So you get the point, right? And what we'll do is it's basically translated to number of recorded passes. And as I mentioned, requirement will not change if you end up having more than 14 sessions. So you can see here just translating the math. A is if you have total number of passes 12 or more. You get a B if your passes are more than 10 or more and less than 12. So basically 10 or 11. And then you get a C grade if your score is 8 or 9, right? So 8 or 9 is C, 10 or 11, 10 and 11 is B, and then 12 and more is A. Okay, so example, if a student attended 12 sessions and scored 70% or higher in 11 out of 12 session quizzes, then you get credit for only 11, and therefore the course grade becomes a B. I mean, it's just an example, right? I'm assuming that with 2 attempts and a simple quiz, you, I mean, I want you to get an excellent grade. So, but to do it the right way. Okay, well, talking about the right way, academic code of conduct. For this course, the honor code is upheld as follows. So you're expected to adhere to the honor code when you record your attendance. So in other words, no cheating on attendance, and you have to take the online quiz. It's okay if you talk to each other about the online quiz, that's fine. I mean, my goal here in offering the quiz is to remind you of some of the key things that happened. And so, you don't have to take it in isolation. It's okay for you to collaborate. But the idea is to draw the learning. Okay. Um, what is not good in terms of taking the quiz is, you close your eyes and you just press whatever your colleague has pressed. I mean, that defeats the purpose, right? So yeah, protect the honor code. That's the bottom line. Okay. Canvas announcement for the week will go out on Sunday with the topic of the week. I will put a preliminary calendar online, and you'll get to see it. But we may make changes along the way because again, we get presenters from all over the place, and sometimes their calendar changes, and then I end up scrambling to find you an alternative. So changes are possible. Okay. Here's an example from spring 23 when I offered this class. And so, I mean, the idea is you have a topic, presenter, role, and so on. So, yeah, we had some interesting speakers here. You can see, we had some conversations on internship, and Dr. Caverly talked about a recommender system. We had conversation on ethics, machine learning, graphics. Uh, some conversation by folks who are working in industry. They talked about bridging theory and practice. We had one of our past students who's fairly senior now in Pixar. He talked about how he applied what he learned in school. So he was in graphics, and he went back and he's a technical director in Pixar, and he talked about what he learned in school, how he applies at work. And then we had the CTO of Marathon talking about blockchain and cryptocurrencies. So you can see, I mean, the idea of showing you this is just to show what we did last time. And obviously, we're going to do something different here because it's hard to get the speakers over and over again. So we'll do something different. I'll share the calendar. Okay, it's going to be on Canvas. All right, so that's pretty much it about our course. And now let's talk about the impact of computing. And I mean, I don't expect any of this to come as a surprise to you, first of all. And also, much of what I'm going to talk about is going to be something you already know. But it's a good idea. And even like I've done this like 3 or 4 times, and every time I talk about it, it just reminds me of some of the really good things that are going on in our field. So for what it is worth, I think it's a good thing to just look at the impact computing is having on our lives across the board. So let's see, development of computers, right? So let's take a peek at the top right here. These are units you hear about every now and then. So I wanted to take a moment and just remind you of what these units really mean. So kilo is 10 to the power of 3, mega is 10 to the power of 6, and on and on and on. And where we are right here is we are in this area right here. And this is where we deal with quadrillions of flops. So what is flops? Floating point operations per second. So these computers, like, you can look at NVIDIA GPU or Intel GPU or Intel CPU or so on and so forth. Um, they're capable of performing large number of operations per second. Floating point operations are really a testimonial to scientific prowess of a computing device. So when we talk about petaflops and exaflops, we're talking about quadrillions of operations per second. So that's the enormity of stuff that happens in one blink of an eye, right? And so this is where we are today. And I'm just going to draw your attention to where we started when we came up with computers, and then where we are today. So let's kind of take an accelerated walk through history. So here, this is the ENIAC, I think first one. And here you can see a bunch of these wires. So the idea was that you pull the wires and you plug them into their respective sockets. And when all of these things were plugged properly, then you'd press a button and then that would make one compute. So the one computation or exercise of a line of program was done by arranging all of these different wires in the different slots, and that was what programming was like. And obviously, it was done by human beings. Then here was a mini computer. So fast forward, like a couple of decades, then we had the Commodore personal computer. This is the first kind of example of a personal computing device, not as compact as a laptop, or say this is a desktop right here. So let's take a look at it again. Actually, I kind of like this look more. And I can tell you that, I'm old enough to say that, yeah, this is when I first got introduced to computers in this generation. And then way later, we had these desktops. I think this is pretty much what a modern one looks like, except that we no longer have towers, at least, unless it's a gaming device. Most of the time, you just have your computes built into the back of the screen. And so here's a laptop and then a bunch of personal devices. And then if that's not enough, then you got computing device in practically everything. And then, no story about computers over unless we talk about these massive, massive data centers that are performing exaflops of operations. So this is where this table is very handy, because all this stuff with weather prediction and earthquakes, forecasting earthquakes, for example, looking into the universe, um, discovery for medicines, vaccines, a lot of that stuff requires amazing amount of computation. So things that were never possible before, just even 10 years before, we are able to do them today because, and of course, I shouldn't miss this whole conversation about AI, right? I mean, if you look at any of the large language models, the reason they exist is because the training is done on billions and billions of pieces of data and compute. So, and that to be able to do that in a decent amount of time requires such processing power. So computers have come a long way in 70 odd years. Well, communication is not left behind either, right? So this one is a little dated, but I think it serves the purpose of communicating the growth. So 5.3 plus billion, this is back like a couple of years back. Now we are about 5.45 billion users. And so that's about 66 point some percent of world's population. So yeah, I mean, that's a lot, right? Two-thirds of the population uses internet. And again, I mean, when you hear your faculty members like myself speak, many of us, we've been around for a long time. And we can say, yeah, I was there. Like for myself, I had started teaching when internet came into what you can say, not even mainstream, just become available to people. So yeah, it's a amazing amount of growth in communication. And then uh, computes, along with computes, which you saw a couple of slides back, and along with internet, there is tremendous number of usage models that are promoting the growth of data. And so just from, I started at Texas A&M here, around here, after I spent a couple of decades building computers. I joined A&M here, and you can see on the relative scale, because this is zettabytes, which is trillion gigabytes, right? I mean, imagine amount of data. And so look at how explosive this thing has been, right? And we're here somewhere right now. So this is the forecast right here. And with the use of large language models and with machine learning, the exchange of data, processing as well as exchange is becoming hugely prolific. So we are in the middle of revolution, and it's changing the way we work and play, and anything else, right? I mean, you just saw pictures of the different forms of compute, and upcoming, I'll talk a little bit about how many of the things that are around us are changing as well. So I think disruptive is probably a good way to describe it, and congratulations to all of you that you are central to this revolution. I mean, every other field is being influenced by computer science. And so, isn't it wonderful that you are at ground zero, affecting, or at least have the opportunity to affect what happens in the future? In case you're wondering, this one looks like a galaxy of sorts, but no, this is the internet, with the backbone and uh, all the end users, right? So it's just a small snapshot right here. So amazing. Yeah. So, well, age of information. Really, I mean, publishing is just has so many diverse forms. You have what you're seeing here is web pages, then news, academic articles, video, and then streaming content, right? So whole bunch of medium of information. When it comes to publishing and media, what you see on the left side here is a traditional newspaper and television, but then you got bloggers and streamers, right? So a lot of that is getting disrupted. Here, digital editing, we are very familiar with being able to, use word processors and edit image and so on. But then you can also there's many different ways of manipulating information. So here you look at this picture and it looks pretty real, right? I mean, you have the jet going near a mountainous region, but you can easily have created this in studio with a jet and then some background that is superimposed in the back. So here, bunch of missiles firing, and then there's plumes of smoke. But if you look at some of this stuff closely as to where things are going and where the smoke is coming, actual pictures on the right. And so, there was another one that was being fired here, but the image was created by just copying and pasting. Deep fake. So here, Forrest Gump, Tom Hanks inserted into video with JFK. So there's a bunch of examples. Here, President Trump And then you have an artist who portrays him on a popular show. And then when you superimpose, you can create a deep fake, which looks like the president, but it's actually a deep fake. And here, Senator Warren, and again portrayed on SNL by Kate McKinnon, and you can see that a deep fake was created for Senator Warren as well. So personal interaction, well, good old days on the left. Then all this stuff right here. Now, something like this is not a surprise. Disrupting retail, here is full malls. I remember the 80s and the 90s fun days, right? In a way. And then now we can buy online. And so the malls are ghost towns at times. Transportation, taxis, yellow cabs, and so on. Now, with the gig economy, you can call an Uber. And then transportation, automation, that's driving things. And so, yeah, Tesla, taxis, there's all kinds of changes. Um, Organization of information. So that's different ways. And then you look at the future, of course, quantum computers are in the offing. And we're looking at 6G right now. 5Gs is very much the norm, and then looking ahead to 6G. Internet of everything means that everything is going to be connected. In many ways, it is connected. So you can see why it's just taken off like wildfire. Robot cooking, and then intelligent buildings, all sorts of connectivity in a building, cars, all sorts of image recognition, recommender systems. This is cybersecurity, maps, health, AI in healthcare, all of this good stuff, right? So the reason I'm showing this is just to make sure that we know our place in history, right? It's in history in the making. Our place is really at ground zero of revolution. We have the opportunity to impact the world in many, many different ways, for good or for bad. I've crossed out the bad because we can only do good. So the CS program is really, the courses you take, the projects you do, all of this is synergized with the objective of helping you learn how to make the following things happen. So first, how do you think computationally, right? I mean, that's all behind the art of programming, um, and testing, how to analyze, how to design, how to develop, right? All of these things are something that are going to be highlighted in many different forms by the course structure that you are going to take in computer science. Let's talk a little bit about jobs. The salaries and opportunities can vary wildly, right, across geography, industry you work in, who you work for, the job you do, background, and general economic conditions. So here's an example, a recent one, right, from April. You can see that this is from labor statistics, that there are a bunch of computer IT occupations. The median pay is pretty high, right? You can see some are master's degree, some are bachelor's degree, but the idea is generally in the neighborhood of 100,000 and plus per year, and it goes up from there. This is some survey that our Career Center does from spring 2024 grads, this is an input. And so we look at computer science right here, and computing, and you can see here median, and this is master's, this is doctorate. Interesting, the reason doctorate is low, I think it is probably because the survey was done for folks who went into academia, right? But in industry, the salaries are much higher. Like this one is really more like what you'd get paid out of school with a doctoral degree in industry. Yeah, bachelor's 90,000. So, TAMU grads are making what I showed you in the previous slide. So it's pretty competitive. Just tons and tons of companies. Career centers coming up. Career fair is coming up very soon. And so you'll get to see a bunch of these companies. Well, unemployment rate globally 4.3%, but computer occupations is pretty good, 2.8%. And when you look at 100 best jobs, 3 or 4 of these are related to our field. So again, a great thing. And that's pretty much it for the conversation on the course introduction. So let me just recall really quick what I want you to do. So first of all, in this first week, there is no in-person class. For this course, we will meet weekly Tuesdays, okay? So no Thursdays. Thursdays only an exception, and I'll tell you way in advance if we're meeting Thursday. Otherwise, the default is every Tuesday. We will meet over Zoom. The link is in student resources and the Zoom logistics. And please, please, please do take care of these 2 following steps. First one is make sure that you have authenticated yourself to tamu.zoom.us. And that's because we need your TamuNet ID. And the second step is go to your profile and then in profile, confirm that your full name, first and last name show up in the profile, okay? We need these 2 things to track your attendance. Without it, we will not be able to give you a passing on attendance, okay? But that's pretty much it. Well, it's great to meet you asynchronously for this first week, and I'll see you in the second week. And in the meantime, I'll be sure to publish a preliminary calendar so you can see what's coming for us during this semester. All right. Take care, you all. Bye-bye.